Okay, so let's see F. Differentiate each of the following functions with respect to x by using the product rule. Okay, so what is product rule? We need to understand it first. Product rule. So the formula is here, product rule. U and V are functions of x. And the more important thing is they are multiplying. Okay, they are multiplying. Okay, so for example, if you have this multiply with this, then this one is known as U, this is V. Okay, so let's say I label it first. This is U, and then this is V. So we have two functions multiply each other, and you are not going to expand it, then you have to use product rule. Of course, you can expand it and differentiate afterwards. That is one way. So, but sometimes the expansion is very hard to do. Then we don't want to do it. Then we use product rule. Okay, so how to use product rule? You see here. This is the formula, and maybe very hard to understand what kind of formula is this. Okay, I explain it in this way. You have y equal to u, v. Okay, let's say u equal to something, u equal to fx, v equal to gx. Okay, so for example, u equal to x squared plus 3, v equal to 2x minus 5. So you can see two functions in x. Okay, same with this one. So now what we need to do is, for the u equal to fx, we need to do differentiation, which is called du dx. So imagine I differentiate the right hand side as well. So I differentiate this, I get f prime of x, let's say in general, f prime of x. Okay, so for example, I have u equal to x squared plus 3. I need to differentiate this equation. So the left hand side becomes du over dx. The right hand side, I differentiate x squared, it becomes 2x. And then plus 3, I differentiate, I will get 0. Okay, then on the right hand side, I have v equal to gx. I differentiate it. Okay, so I will get dv dx equal to g prime of x. Okay, for example, for our case here, we have v equal to 2x minus 5. We differentiate it. dv dx equal to, I know 2x, differentiate, it becomes 2. Minus 5, I differentiate, no more. So I have du dx and dv dx found. Okay, so after I find this, what we need to do is we have to use this formula to get our dy dx. Okay, so how to use this formula? Let's take a look. In general, dy dx equal to, okay, you see we take u first. That means when we say we take u, right, that means we take fx first. We put back our fx, and then we make it multiply with dv dx. dv dx means this one, g prime of x. Multiply with g prime of x plus, okay, now followed by v. v is gx. gx multiply with du dx, which is f prime of x. f prime of x. So let's say example. So based on the formula here, okay, the formula over there, so what we can do is to find dy dx, first we write u, which is x squared plus 3. So we put x squared plus 3 first, followed by dv dx. dv dx is this one, which is 2. So we put 2 here, followed by plus, followed by v. As you can see, v after that. So v is 2x minus 5. So we put at the back here. 2x minus 5, followed by du dx. du dx is 2x. So we put 2x here. So to make it easy, right, you may think of cross multiply like this. This one cross multiply with this, and then plus v cross multiply with du dx. They are like cross multiply in that way. So once we have cross multiply and add up, then we just need to simplify our answer. So we simplify it in this way. Imagine I times 2 with this and this. I times 2x with this and this. So I simplified it, and then I will get 2x squared plus 6. Then the back one is 4x squared minus 10x. And then one more steps, I simplify the terms here. I will get 6x squared minus 10x plus 6. So that is the final answer, which is dy dx. So that is the way. I show alternative here as your reference. Like what I said, if you don't want to use product rule, then you need to expand it. Okay, let's say I expand it and you try to see what happens. So you expand like usual, then you get y equal to 2x cubed minus 5x squared plus 6x minus 15. So I expand already, and then I differentiate. So if you still remember the formula of differentiation, so we have to put the power in front and multiply. So 3 times 2 is 6. Then you have to minus 1 with the power, you get power 2. And then 5x squared, so the square you bring in front and multiply with the minus 5. So minus 5 times 2 is minus 10. Minus 10x. Okay, now the 6x, which is the special case. 6x you differentiate, you get 6. So what we realize is same answer. Same answer. But the thing is, sometimes we must use product rule. We must use product rule to get answer. If the question asks you to do so, especially. Okay, so if the question never asks anything, right, never say anything, so you can use product rule if it is very difficult to expand. But if it's very easy to expand like this one is very easy to expand, and then you expand, then you differentiate term by term. So if it's very hard to expand, and then you don't expand, you use product rule. Okay, so that's the thing. Okay, let's see one more example. Of course, our focus today is product rule. Okay, it's product rule. So that's why even though you feel like not necessary to use it, but we are still using it for practice purpose. Like for example, right, this one, if I'm not going to use product rule, I just expand, just expand, then I differentiate. But the question said you have to use product rule, and then we have to use it. For this case also, you see, I can easily expand and use it. So let's see one more example. Okay, let's say question 4. You see how I use product rule again. The front part, u. The back one, v. So u equal to 2 over 3x. And when you want to differentiate this, right, you have to bring up the x. The x only. The 3, just leave it at the bottom. And then you do du dx. So the power, minus 1, you multiply with 2 over 3. So you get minus 2 over 3. and then the power minus 1, you minus 1 again, you get minus 2. Okay, that's your du dx. And after that, the v is 6x minus 5. The dv dx is 6. Then dy dx is like this multiplied with this plus this multiplied with that. Okay, so u is 2 over 3x multiplied with dv dx, which is 6, plus v which is 6x minus 5 multiplied with du dx, which is minus 2 over, okay, let's say I simplified it at the same time, minus 2 over 3x squared. The x squared, I bring it down, minus 2 over 3x squared. Okay, then I will get my dy dx. I just need to simplify this. I know 6 and 3 I can just cut in and it becomes 2 only. 2 times 2 is 4 over x. And then this one I cannot do anything, so I just leave it like this. Okay, so this is my, oh, I think I can simplify a little bit. Okay, let me multiply inside. I just realized after I expand, I can simplify a little bit. So this time this, and then this time this. So when I take this multiply with 6x, okay, first I will get 6 times 2 is 12. 12 over 3 is 4. I will get minus 4. Then I know x over x squared is just x, so I will get this. So I realize I can simplify because of this. Plus 10 over 3x squared. And then I can cut these 2 away. 10 over 3x squared, the final answer. So that is product rules. And then we have another rule, which is in part G. So you can see it here. Differentiate each of the following function with respect to x by using the quotient rule. Okay, quotient rule is used in fraction. Product rule is used when there are two functions of x that are multiplying. Okay, now let's look at the formula quotient rule, which is here. U and v are functions of x that divide. The numerator, you just take it as u, the denominator as v. Okay, so the way to do it will be more or less the same like the product rule. So for example, y equal to u over v. So let's say the function on top is fx. So u is fx. The function at the bottom is v. Let's say it's gx. So what we need to do is we differentiate. You get du dx. Then for the v equal to gx, we differentiate. Then we get g prime x. Okay. Just now, right, when I explained product rule, I said you just cross multiply like this. Okay. But now when you use quotient rule, right, we are still cross multiply, but we have to start with v cross multiply with du dx first. As you can see the formula, which is here. V cross multiply with du dx. So this one must start first. Then followed by this. Okay, let's say I use different color so that you remember. The green color start first. Okay, so which means when you want to get your dy dx, you must put v cross multiply with du dx, then minus with u cross multiply with dv dx. And then you still need to do one more thing, which is divide by v squared. So for our example here, the v is gx. The du dx is f prime of x. The u is fx. the dv dx is g prime of x. Then divide by v square. Our v is gx. Then power 2. So the formula is like that. And let's see one example. I will use this as my example. So the top one is u. The bottom one is v. When you see fractions, if you can't simplify it, and then you have to use quotient rule. But sometimes fraction we can simplify. For example, if you have y equal to, y equal to 2x plus 1 over x. For this case, right, no need to use quotient rule because we can simplify like this. If it is one terms at the bottom, we can simplify. We take 2x divided by x. 2x divided by x. Then we take 1 divided by x. And then we get 2 plus x minus 1. And then we can do differentiation without using quotient rule. If you can simplify, then don't use quotient rule. If you have no choice, cannot simplify, then you use quotient rule. So let's say, for example, this one, I finish it. Differentiate 2 becomes 0. Differentiate this, the minus 1 come in front. Minus x minus 2. Minus 1 over x squared. So this is the example where we can avoid quotient rule because we can divide. If the bottom is one term, we can divide. But if the bottom has two terms, we cannot divide. You don't expect to divide like 2x divided by 3x, 1 divided by 4, cannot. So cannot. So if cannot, that means we have to use quotient rule. Okay, so u equal to 2x plus 1 du dx. Differentiate 2x, you get 2. Differentiate 1, you get nothing. Okay, then the bottom is v. v equal to 3x minus 4. dv dx equal to 3. Then we cross multiply, but must start from v first. v cross with this one. Okay, so we write dy dx is equal to v followed by du dx, then minus. The formula for quotient rule is minus, but product rule just now, as you can see, product rule is plus. So it's plus, but this one is minus. Okay, so minus. Okay, now we have u. u is 2x plus 1. dv dx is 3. Divide by v square, which is 3x minus 4 square. And then we just need to simplify. How we simplify? Remember one thing, this and this cannot cut. So we have to expand it. We take 2 multiply with 3x, then we get 6x. 2 multiply with 4, we get minus 8. And then likewise, 3 multiply with 2x, we get 6x. And because of the negative, we have minus 6x. And then 3 multiply with 1, we get positive 3. And then because of this negative, we get negative 3. At the bottom, v square. This v square, we just leave it like that. No need to expand. And then let's say I put the final answer here. Minus 11 over 3x minus 4 square. That's the final answer. So this is quotient rule. Okay, quotient rule. Set the. Okay, now let's move on. Okay. Now when you look at this part H, right? They say differentiate each of the following function with respect to x by using suitable rules. Suitable rules. You see question 1. Y equal to this times this. Then you may think of, can I expand it or not, so that I don't want to use product rule. Very hard to expand. You see power 3. This is power 4. So expanding this is not practical because it's hard to expand. Okay, so we use product rule then. when you want to use product rule, you must remember your chain rule. So let's do a quick revision. Chain rule. So revision on chain rule. If you have y equal to something with power, okay, the differentiation is you bring this power in front and then you just write back whatever in the bracket, then the power becomes n minus 1. Then one more step, you still need to differentiate whatever you have in the bracket. That means you differentiate the fx, then you get f prime x. So this is chain rule. In general, it looks like this. Of course, if the chain rule involving linear form in the bracket, and then the chain rule looks simple. Okay, for example, power n, put in front, multiply with the bracket, the power becomes n minus 1. Then you still need to differentiate whatever you have in the bracket. Differentiate the fx, become f prime x. For our case here, differentiate ax plus b. So differentiate ax, you get a. Differentiate b, you get nothing. Okay, so this is chain rule. You have to use chain rule to get the differentiation. Okay, let's see how. So you see this is u, this is v. They are multiplying. We have to use product rules. So we have to let u equal to x minus 2 power 3. So when you want to do du dx, you have to apply chain rule. Okay, so product rule and chain rule come together now. So I use chain rule to differentiate the u. So power 3 move in front. Then write back the bracket. Then the power 3, you minus 1 become power 2. And you still need to differentiate the x, it becomes 1. Then end up with 3x minus 2 squared. That's your du dx. Now for the v, 2x minus 3 power 4. Again, we have to use chain rule to find dv dx. So according to chain rule, power 4 move in front. Write back everything in the bracket. Power 4 become power 3. Differentiate whatever you have in the bracket. 2x differentiate and get 2. Minus 3 differentiate and get 0. So only 2 remain. And then we get 8. 2x minus 3 cube. So we have du dx and dv dx. Now we cross multiply. So u cross multiply with dv dx, v cross multiply with du dx. So that is the formula of product rule, which start from u, followed by dv dx, followed by v, followed by du dx. So after using the product rule formula, now we need to simplify our results here. So we need to simplify this. Simplify this by factorization. Okay, simplify by factorization. Okay, I do it here. I just put a small note here. Factorize them. Factorize. Okay, so how to factorize? Now this is one term, this is the second term. So when you want to simplify them by factorize, you have to see the same things in the two terms over there. Whatever same, you just factorize it. That means you just take it out. So for example, I have x minus 2 power 3, I have x minus 2 power 2. Okay, so I can factorize x minus 2. But the thing is, factorize x minus 2 power 3 or x minus 2 power 2. We take the smaller power. We factorize the smaller power. So imagine dy dx equal to, okay, I factorize the smaller power, x minus 2 power 2. Then the rest I put at the back. I factorize the smaller power. So before I write down what remain in the bracket, you imagine first. When I factorize x minus 2 power 2, right? So this one no more already, still have power 1. The power 3 become power 1, as power 2 has been taken away. So for the second term, the x minus 2 power 2 is just factorized completely out from the second term, so no more. Okay, so that means by factorizing x minus 2 power 2, this one only power 1 remain, this one no more. Okay, so I don't want to write at the back first because I'm still able to factorize something else. I still have this 2x minus 3 power 3, 2x minus 3 power 4. I'm able to factorize, and remember, when you factorize, you use the smaller power. Power 3, power 4, factorize the smaller power. Factorize 2x minus 3 power 3. Okay, now imagine. When I factorize 2x minus 3 power 3, this whole term disappear. This whole term disappear. Power 3 has been taken out totally. And for this is power 4. 2x minus 3 power 4. So you take out power 3, right? You still have power 1 remain. So still have power 1. Okay, so I just cut the power 4, change it to power 1. Okay, so likewise, if you have number that has a common multiples, you can factorize also. But 8 and 3, there is no common multiple, so I cannot factorize that. Okay, so now I write what's remain. After factorizing these two, what remain I put at the bracket at the back. So I still have x minus 2 power 1. I still have 8 that multiply with this. Okay, so I put the 8. Followed by plus. I put a plus. Followed by 2x minus 3 power 1. I just write 2x minus 3. Power 1 is not necessary to write. And then I still have 3 that multiply with this 2x minus 3. So I still have a 3 at the back. So that is what remain. After factorize those common things, I still have this. Okay, now the front part, I just write back. But for the back one, I expand it. So I expand like 8 times this, 8 times this, 3 times this, and 3 times this. So I expand in that way. So I will get 8x minus 16 plus 6x minus 9. Okay. So for the front part, I just remain 8. For the back one, I simplified it. 8x plus 6x, I get 14x. Minus 16 minus 9, I get minus 25. So that is the final answer. So we have to factorize it, and it's not that easy for most people. Okay, now let's see another situation. Let's say question 3. You see, it's a fraction, so we have to use quotient rule. Quotient rule. Okay, so the top one is u, the bottom one is v. So u equal to 4x plus 1 power 3, v equal to x plus 6 power 2. Okay, now when you do du dx, you have to apply chain rule to differentiate it. Chain rule, okay, where the power 3 move in front, then 4x plus 1, the power 3 you minus 1 become power 2, and you still need to differentiate whatever you have in the bracket. Differentiate the 4x plus 1, and the 4x differentiate and become 4. The 1 differentiate and no more, so you have 12, 4x plus 1 power 2. That's your du dx. Now for the dv dx, we have to use chain rule again. So power 2 move in front, then x plus 6 power 1. Differentiate whatever you have in the bracket. Differentiate x become 1. Differentiate 6 becomes 0. So just have 1 that remain. So end up with 2x plus 6. Okay. Now we use quotient rule. dy over dx equal to, okay, if you still remember this, multiply with this first. So followed by this, multiply with this. The green color comes first. Okay, so x plus 6 power 2 multiply with 12, 4x plus 1 power 2 minus u, 4x plus 1 power 3 multiply with 2x plus 6 divide by v square, our formula v square, x plus 6 power 2 and power 2 again, so it becomes power 4. So that is v square at the bottom. For the v square at the bottom, no need to do anything, just leave it there. Okay, now for the top one, we need to factorize whatever common. So imagine all these that multiply are the first term, and all these are the second terms. And you have to see the common things here. Okay, for example, I have x plus 6 power 2, I have x plus 6 power 1. So I factorize the smaller power, which is x plus 6 power 1. So I cut away. X plus 6 no more. X plus 6 power 1. Sorry, x plus 6 power 2 become power 1. Now, the other common thing is 4x plus 1 power 2 and 4x plus 1 power 3. So I have power 2 and power 3, I factorize the smaller power. Factorize power 2. Okay, so imagine I factorize 4x plus 1 power 2. And imagine I cut away. 4x plus 1 power 2, gone. 4x plus 1 power 3, still have power 1 that remain. Okay, don't forget about the numbers here, 12 and 2. So what is common here is I can factorize 2. Okay, I factorize 2. Now imagine for the 12 in front, after factorizing 2, I still have 6. For the 2 at the back here, after factorizing 2, no more already. No more. Okay, so I factorize whatever possible, and whatever remain I put at the back. So you can see I still have x plus 6 power 1 and 6. X plus 6 and 6. Okay, followed by minus. Followed by 4x plus 1 power 1. And all this no more already. So only 4x plus 1. And at the bottom, x plus 6 power 4. So after you factorize, right, if you see anything same with the bottom, you can cut. After factorize, you can do so. Before factorize, don't do that. Okay. If you want to cut with this, right, you must factorize it first. So I have factorized x plus 6. Now I can cut with x plus 6 power 4 at the bottom. So imagine the x plus 6, no more. And this one you cut away one of them, you still have power 3. Okay, I continue here. So the dy dx is hence 2 4x plus 1 power 2. And at the meantime, I'm going to simplify everything at the back here. I times 6 to x times 6 to 6. So I will get 6x plus 36 minus 4x minus 1 over x plus 6 power 3. Then continue to 4x plus 1 power 2. Okay, now you imagine I'm simplifying 6x and 4x. I get 2x. 36 minus 1, I get 35. So at the bottom, x plus 6 power 3.